Good day guys, welcome back to Wiki Science YouTube channel. In this video, I'll put you guys through what we refer to as electrostatics. This is an important aspect you need to know in physics, most especially when you're sitting for any physics examination. So guys, let's get started. What is electrostatics? Now, this term is derived from two words. We have the electric charge and as well the term statics. The word electric charge simplified or simply means the fundamental property of an atom that make up a matter. So you can call it the fundamental property or you call it the intrinsic property or fundamental attributes. But when it comes to the case of this is the fundamental attributes of matter, while the statics defines at rest. It defines a body at rest, not moving. So therefore we can simply say that electrostatics is defined as the study of electric charges at rest. However, the electric charges can simply present some various aspects which you need to know more better. These include the electric field. We have the electric field lines. We can as well have the electric force. We can have the electric field potential. We can also have the electric current. We can as well have the electric circuit. Also, we can have the electric field flux and many other aspects that which the electric charge can result into. But in the course of this video, we'll limit it to aspect of electric field lines. I'll also talk about the electric force. Let's continue with respect to electric charge. Don't forget to say that electric charge is a fundamental attribute of matter. However, I want you to know that in an atom consists of proton, neutron, and electron. In the nucleus of an atom, that is where you have the protons and you as well have the neutrons. The proton is said to be positively charged, while neutron it has no charge. However, it is surrounded in an orbital or shell by electrons. The electrons are said to be negatively charged. Now, the protons are attracted together by a nuclear force. So the force that exists between protons is called the nuclear force. And this force attracts the protons together. However, when we consider the protons and the electrons are attracted together by what we refer to as the electrostatic force. So what exists between the protons and electrons is called the electrostatic force. Electrostatic force. It's called the electrostatic force. Now here, we can quickly look at some various rules or principles guiding or governing an electric charge. The first one is the fundamental principle of electric charge. And the fundamental principle of electric charge states that like charges repel while unlike charges they attract. Meaning when I have a positively charged particle and a positive charged particle, what we have here will be repulsion. As well, when I have a positive charged particle and a negative charged particle, what I have here will be attraction. When I also have a negative charge particle and a negative charge particle, it will also result into a repulsion. So here we have repulsive forces existing between these charges. Okay, aside from this, we still have two other principles governing electric charge. The second one is called the principle of conservation. The principle of conservation. So the principle of conservation states that the algebraic sum of charges in an isolated system or in an isolated body is equal to 0. The algebraic sum. So here, this is because in an atom, you always have protons and electrons. And since we said that protons are positively charged, electrons are negatively charged, this makes it what? 0. This is why we call it law of conservation of charges. The third one is called the law of quantization of charges. The law of quantization of charges states that the total charge on a body or particle is equal to the integral multiple of protons or electrons that make up the charge. So here, when I have a body here, the body is said to be Q. Now, in this body, you can have several electrons or you can have several protons. Here, the number of these protons times, that is the multiple of these protons times the number that exists is equal to the total number of charges. So here, this Q is the total charge. This is the total charge. Where you have your N to be the quantum number. We call this now the quantum number. And this refers to the total number of electrons or protons that make up a charge. And you also have the E to be your electrons. Sometimes it might not be electrons, it can definitely be protons. And here you can also have P to be your protons. Now here, we want you to know definitely well that the charge of electrons and the charge of protons are the same in magnitude. But what is different here is the charges. So here we have the electron to be negatively charged and we have the protons to be positively charged. But they have equal magnitude. With respect to this principle, let's look at some questions and we quickly answer those questions. Here we have two different questions which we're going to take one after the other. The first one is that the charge on a particle is 2 times 10 raised to the power minus 4 coulomb. Determine the charge quantum number. Here we are asked to determine the charge quantum number, but initially we've been given the charge on the particle to be 2 times 10 raised to the power minus 4 coulomb. Please do not forget this. And here, you always have it that the charge of electron or charge of proton is said to be 1.602 times 10 raised to the power minus 19 coulomb. Please do not forget this. So here, to get the quantum number here, we can say that using the formula related to the quantization of charges, that our Q is equal to NE. The value of Q is 2 times 10 raised to the power minus 4. The N is what we're looking for, and the number of electron referred to, the charge of electron referred to is 1.602 times 10 raised to the power minus 19. Now, when we make N the subject of formula, we simply have the expression to be given as 2 times 10 raised to the power minus 4 divided by 1.602 times 10 raised to the power minus 19. And from here, we can get the value of N to be 1.248. That's 248 times 10 raised to the power 15. That is our value. Times 10 raised to the power 15. That's our value. Now, let's answer the second question. You can see it's very easy to get. Now, here, what is the total charge in coulombs of all the electrons in 3 moles of hydrogen atoms? Now, to as well get this, now I'll quickly take you to an expression which you have for mole. What is that expression? You always have that your mole is equal to number of atoms over 6.02 times 10 raised to the power 23 atoms. That is Avogadro's number. Okay, from this expression which you have for both, we can easily get the number of atoms that we're dealing with. And here, the number of mole given is said to be 3, and the number of atoms, we can represent it to our n, and we have to be 6.02 times 10 raised to the power 23. So here we can get our n to be 1.806 times 10 raised to the power 24, raised to the power 24. So here, don't forget the expression which I've given you for the total charge. For the total charge, you have that your Q is equal to Ne. And here you have our Q now to be N is 1.806 times 10 raised to the power 24 times your number of electrons, which I've given you earlier to be 1.602 times 10 raised to the power minus 19. So here your total charge here will be said to be 2.89 times 10 raised to the power, so that is raised to the power 5 coulomb. This is our answer. Now, it is very easy to calculate the total charge or number of or the quantum number, as the case may be. So right now, we look at the electric field. Now, electric field is a region or space in which an electric force can be experienced or felt. So in this case now, when I place a charge in a region, it's going to create an electric field. And this electric field is mapped out by what we refer to as electric lines. Now, these electric lines is used to determine whether the electric field will be a strong electric field or a weak electric field. If it is a strong electric field, the electric lines are said to be closer together. For instance, when we talk about the electric field that exists between a positive charge and a negative charge, we can actually have something like this, in which the electric lines are said to be very much closer. They are close together. But when it is said to be a weak electric field, these electric lines may be said to be very much far apart. And here you can have something like this, and you can just have like this. So they are very much far apart. Now, in this case, we can also talk about the electric force. Now, to talk about the electric force can be expressed in terms of the Coulomb's law, or you can say it can be quantified in terms of Coulomb's law. The Coulomb's law is also what we refer to as the inverse square law. And what does this state? The inverse square law states that the force of attraction or of repulsion between 2 point charges is directly proportional to the product of their charges and inversely proportional to the square of distance apart. So when the charges are the points closer to each other, we can easily get or determine the electric force. So here we can say that the electric force between charge Q1 and another charge Q2 here, which we denote with F. The F is a force. So the electric force is said to be directly proportional to the product of their charges Q1, you have Q2. This F is also inversely proportional to the square of distance apart. So if we assume this to be R, which is the distance between both charges, then we can combine these two expressions by saying that our F is directly proportional to Q1, Q2 all over R squared. So here, for every sign of proportionality, there's always need for a constant. And the constant introduced here is K, which is K1, and you have Q2 and KQ1, Q2 over R squared. The value of K is said to be, which is referred to as the electric constant, is equal to 1 over 4 pi A naught, and you have it to be is the same as 9 times 10 to the power 9 Newton meter squared per coulomb squared. Now, for this permittivity, we call it the permittivity of free space. Permittivity of free space. And whenever we're dealing with charges that are not in a free space, then we can use a definite relative permittivity to get the electric constant. In this case, now we can put the expression to be K equals 1 over 4 pi E naught ER. That is when that particular substance now is in another medium, not in a free space. How do I arrive at this? This is because whenever we're dealing with relative permittivity, our relative permittivity is the permittivity of a medium over permittivity of free space. And since permittivity of the medium, permittivity of free space, and since the permittivity of the medium is said to be your relative permittivity times the permittivity of free space, you can bring that here. So instead of me writing EM, which is the permittivity of the medium, I'm simply writing the relative permittivity, the product of the relative permittivity and the permittivity of free space. That's what I'm putting in here. And that was how I arrive at this. So if it is not occurring in free space, it will be occurring in a medium, and can present it as this. Okay, with respect to this now, I have several charges along a straight line. And in this case now, we can be asked to determine the electric force that exists between them. In this case, we can have it to be Q1, Q2, Q3, and as well have it to be Q4. Now we have a reference charge with respect to all of this, and the reference charge can be taken to be Q1. Now when the reference charge is given as Q1, and we have it to be Q2 over the distance between Q1 and Q2, so I'll just write 1, 2 because it's between 1 and 2. Don't forget your distance is always square. Plus the same K in bracket, your reference charge, which is Q1, with respect to the third charge, which is Q3, over here you have to be 1 and you have 3 all squared. You can also take it here that your K, you have your reference charge, which is Q1, and you have your last charge, which is Q4, and here you have to be R1 and you have 4 all squared. The sum of all the electric force between the charges along a straight line denotes your equivalent or resultant electric force. In some certain aspects, you can have it to be you can have dash like to the number of charges. That is, the charge can continue. It can be more than 4. It can be more than 5. It can be more than 6. Like that. You just continue like that in that particular progression. Now we'll take one example here, and we use it to actually conclude this aspect of electric force. Now the question is, example 1, the question is that calculate the electrostatic force between two protons separated by a distance of 1.5 times 10 to the power minus 11. Okay, let's get the force. We have to be solution. The force here is said to be KQ1 Q2 over R squared. And here, don't forget the value of K. The value of K is said to be 9 times 10 raised to the power 9. And the value of Q1 is said to be, that is your proton. Don't forget, proton is said to be 1.602 times 10 raised to the power 19 minus 19 coulomb. But here, proton is positively charged. So you have to be 1.602 times 10 to the power minus 19 times another 1.602 times 10 to the power minus 19. Everything divided by the distance. The distance between them is said to be 1.5 times 10 to the power minus 11. So here your F is said to be simply, a simpler way to actually go about this is by multiplying all the numbers together and divide by the value you have below. Don't forget, this is actually squared. So when we multiply out all of this expression, we arrive at 1.03 times 10 to the power minus 6, minus 6 Newton. So that's all about the electric force. Now we've come to the end of this video, and I believe that this video has been really so much helpful and comprehensive. In the next video, we'll look at other aspects of this electrostatics. So please, I want you guys to stay tuned and watch other videos. Thank you for watching this video to the end, and we'll see you next time. Bye.